Hi everyone, it is Sri Devi, Professor of Department of Electronics and Communication Engineering, Logini College of Engineering and Technology. In this video lecture, we are going to learn about Hamming codes and its properties, which was categorized under linear block code.
Logini College of Engineering and Technology. On completion of this module, the learners can able to understand the basic concept about Hamming codes. The linearity property of the code word, the sum of two code words is also a code word, that is called as a linearity property. Simply this property states that if there are two code words, if we are adding these two code words, the addition or the sum of these two code words will produce a code word only. So sum of two code words will also a code word. The Hamming codes are the type of linear error control codes, and it can be detect up to 2 bits of errors, and it can also correct to detect 2 errors and correct a single error. That is the basic concept of Hamming code. So a Hamming code is the same set of linear block codes, and it is represented as n, k. While using this Hamming code, extra parity bits are used to identify the single bit error. So to get a 1 bit pattern to the other, few bits are all can be changed into the data. Such number of bits can be termed as Hamming distance. So there is some properties related with the Hamming codes, that is called as first one is the number of check bits q is always greater than or equal to 3. The block length n is equal to 2 power q minus 1, and number of message bits k equal to n minus q, and minimum distance d minimum equal to 3. So the Hamming weight of the code is calculated as the largest number of ones in a valid code word. We have to count the number of ones. The number of ones in a code word is called as Hamming weight. The number is 3 among the 10 code words we have chosen. Then we can tell that Hamming weight is 3. If the parity has the distance of 2, one bit flip can be detected and one bit flip can be corrected. So there is one formula for coding Hamming rate or code rate r equal to k by n. K is determined by number of message bits, that is k equal to n minus q by n. So it can be n by n minus q by n, that is r equal to 1 minus q by n. In Euclidean concepts, we can measure the distance, that is Euclidean distance in continuous variables. We can calculate the distance as the Euclidean distance. The Hamming distance between two sequences 001 and 101. How to calculate this? Let us check bit by bit. Here in the first code word, let us consider a equal to 001. Consider the second code word b equal to 101. Compare a and b. So first bit is 0 in a, and first bit in b is 1. So 0 and 1. So there is one variation. Okay, let us have this variation 1. Second bit is 0, and here in b second bit is 0, no variation. Let us come to the third bit. Third bit is 1. Here the b third bit is also 1. So there is no variation in third bit position. So we can conclude that in the second bit and third bit positions there is no variation, and there is one variation in the first bit position. So there is only one variation, so we can consider that as 1. So this is called as Hamming weight. Also we can calculate error detection and correction capabilities. So the error detection capability is it can able to detect 2 bit errors, and it can able to correct 1 bit error. Error detection capabilities can be determined as d minimum should be always satisfy the condition that d minimum is always greater than or equal to t is equal to d minimum minus 1. And error detection and error correction capabilities for detecting 2 bit errors, d minimum equal to 2t plus 1. So t is equal to d minimum minus 1 by 2. So always the chord length is equal to n equal to 2m minus 1, and m is greater than 3, that is the Hamming distance, that is an integer. Number of message bits k equal to 2m minus m minus 1. Number of parity check bits n minus k equal to m. The important property of Hamming codes is that it satisfies the condition that the equality sign, assuming that t equal to 1, once the redundant bit is embedded within the message that is sent to the user. So Hamming code can be the procedure for calculating the Hamming code can be produced as by the steps. Step 1, calculating number of redundant bits. Step 2, positioning the redundant bits, and third one is calculating the values of each redundant bit. I have one quiz question here. What is the minimal Hamming distance between any two code words to correct errors? For correction, the minimum distance should be 3. So always to correct the Hamming code, the minimum distance should be 3. So we have the generalized version of Hamming code 7,4. The minimum Hamming distance is 7 minus 4 equal to 3. So it cannot correct burst errors. Thank you.